Hi there and welcome again to linear algebra. Here in this video we want to find the product of two matrices. In other words, we want to find out how to multiply a matrix A with another matrix B. Remember, we had some conditions for addition. If we are to add two matrices or subtract one matrix from the other, we need to make sure the two matrices are of the same size. Is that the same condition as for multiplication? No. In multiplication, we have to take note of the following condition. Supposing our matrix A is of size M by N. This will be matrix A. And our matrix B is size N by P. In other words, M rows, N columns, N rows, P columns. If this product is to be possible, we check here. The number of columns in A must be equal to the number of rows in B. Remember, we start with rows and columns, rows and columns. So the columns in A must be equal to the number of rows in B. What will be the size of the product? The product will be of size M by P. In other words, the product will have M rows and P columns. Now we do have two matrices here, A and B. What are their respective sizes? A is a 2 by 3 matrix. B is a 3 by 2 matrix. So we have A, it's 2 by 3. What about B? It's 3 by 2. So that is satisfied. Number of columns in A equals number of rows in B. What will be the size of the product of A and B? It will be a 2 by 2 matrix. Okay? So let's keep this in mind. Let's now get busy and multiply A and B. So what we have here, we'll put our A here. It's 3, 4, 9, 0, 1, 2. Multiplying our B, 1, 9, 0, 2, 3, 1. Remember, in addition, you add corresponding elements. In multiplication, it's slightly different. Here is how it goes. You multiply the whole of the first row of A by the first column. You also multiply the second row by the very first column of B again. So let's do that and see. So we are going to have our first element in the product will be 3 multiplied by that, by 1, and plus a 4 multiplied by a 9. So 4 multiplied by 9 here, plus a 9 here multiplied by a 0, which is 0 times 9. Notice how we are coming down. 3 by 1, 4 by 9, 9 by 0. That's what we have here. Then what else? We come over here and we say 0 multiplied by 1, 1 multiplied by 9, plus a 2 multiplied by a 1. This one here. Okay, are my elements going to fit here? I wonder. Okay, then we come over here. Now we are multiplying all the rows of A by this last column. Remember, first we multiply all the 2 rows by this first column here, and we got the first 2 elements of A of the first column. Now we want the second 2 elements of the second column of our product. We multiply this by that, and this by that. So let's do that. It's a 3 multiplied by a 2, so which is 3 by 2. I'll try and make it smaller. I want to fit it there. A 4 multiplied by a 3 plus a 4 multiplied by a 3. I hope you can see that. Plus a 9 multiplied by a 1. A 9 multiplied by a 1. Oh, it's getting too tiny now. Then we come over here again. A 0 multiplied by a 2. So 0 multiplied by 2. A 1 multiplied by a 3 plus 1 multiplied by 3 plus a 2 multiplied by a 1 plus a 2 multiplied by a 1. Let's just slowly repeat what we did. The first element in our product is what we get by multiplying the first row by the first column of B. That's what we have here. The second element in the first column, we get it by multiplying our second row by the same first column of B. To get the elements in the second column, we multiply all the rows of A by the second column. So we have all this multiplied by that, which is what we have here. And we have all this multiplied by that, which is what we have down here. Let's write it somewhere here. Adding together, we write it somewhere here. I know it's looking a little bit messy. I beg your pardon for that. So 3 times 1, which is 3, plus 36, which is 39, plus 0 is just 39. 0 times 1 is 0, plus 9, which is 9, plus a 2, that gives us 11. 2 times 3 is 6, plus 12 is 18, plus 9 is a 27. 0 times 2 is 0, plus 3 is 3, plus 2, it's a 5. So that is what you get when you multiply A times B.